on the left hand side of -3, because between -3 and 1 it will not be there. Now we have to check for -3, again it's 0. Okay. And at -5 you will get the minimum value, and at x is equal to -infinity it will be 1. So the graph at -5 you get the maximum value, sorry, the minimum value. So the graph goes something like this, comes back and merges with this. Okay. Okay. If you are not happy with the graph, you can use Desmos and check it. It's a graphing calculator is there. So if you check the range, it's very interesting. Maximum value is not 1, it's like slightly lesser than 1. So the range will be lesser than 1, but greater than or equal to -2 by √3. So what we did it earlier was wrong. We got this as a range without understanding. So in range, this was a specific problem where the domain played an important role in solving it. Okay. So make a note of this graph. You may ask how I came to know this. I forgot to tell that how the graph is intersecting. So it's very simple. Okay, can I put 1 here? Okay. If I put 1 is equal to x square plus 2x minus 3 divided by x square plus 4x minus 4. If you simplify, you get x square plus 4x minus 4 is equal to x square plus 2x minus 3. So x square get cancelled. So 2x is equal to -7. So x is equal to -7 by 2. So at -3.5, that is -7 by 2, the graph intersect y is equal to -1. But on the right hand side, it never intersects. That's the story. On the right hand side, it never intersects. All of you, I hope, understood. Can anyone reply if you have a doubt? Shall I move to next problem? Anyone can reply? Yes?
Yes, sir.
Okay. So, okay, fine. So, this is a range problem again, correct? Did I write the question correctly? 8x minus x square root under. Okay. Just when someone is. Fine. and root of 14x minus x square minus 48. That's the, again, if you differentiate it, it will be complicated to do it. You can try, no issues, to find out the maximum minimum. But there is a graphical interpretation. Why I'm teaching all this stuff? You know better ways of solving a problem. So what I'm going to do, you look at it. Correct. I want to write this as a square, kind of a distance formula. If I take minus common, it is 8 square minus 8x plus 16. दे दो राजू यहाँ 16 minus, okay. Here if I take minus common, it is x square minus 14x. So to make it square, I need to write 49. So here I'll write 1. Is it okay? I just wanted to make it into whole square. X square minus 8x. So to make it square, coefficient of x is 8, half of 8 is 4, so square of 4 is 16. So I subtracted, added 16, 16 get cancelled. Here x square minus 1 for 14x. So coefficient of x is 1 for 14. Half of 14 is 7, square of 7 is 49. So 1 minus. Okay. So this is 16 minus x minus 4 the whole square plus 1 into x minus 7 the whole square. Okay. Sorry, this in between minuses. Sorry, my root. Yes. So this is so suppose this is y1, this is y2 for a moment. Rather than calculating, we just understand what. So if you square y1, you get y1 square is equal to 16 minus x minus 4 the whole square. And y2 square is equal to 1 square minus x minus 7 the whole square. So if I bring this side, it will be x minus 4 the whole square. y1 square is equal to 16. X minus 7 the whole square plus y2 square is equal to 1 square. Okay. Both, if you analyze it, both represent the equation of a circle. Okay. And I preferably tell it's a semicircle because y1 is positive as well as y2 is also positive, but both are semicircle. So can we draw both the semicircle? Yeah. This is one of the center is 4, 0 and one of the center is 7, 0. So say this is 4, 0 with a radius of 4. This is 4 square is 16. So extremities will be, if I take a radius of 4, this length is 4, this point, if this is 4, this will be 8, 0. Again, if this is 4, this will be 0, 0. Okay. So you get a semicircle like this. So this is the domain. As x increases, y will increase as well as decrease. Okay. Maximum value of y1 will be the radius of the circle, that's 4. And if you recall, if you see it, this second equation is also a circle whose center is 7, 0 and the radius is 1. Center is 7, so just 1 unit ahead of it. A small circle will come. Sorry, small semicircle. And it will be the upper part of semicircle because y2 is positive. Okay. So for the same value of x, you need to find y1 minus y2. That's it. So, okay. I drew it. Here, if you take for the same value of x, this is y2 and the bigger one is y1. So you need to find out this difference, y1 minus y2. This difference you need to find out, y1 minus y2. Okay. Okay, so if I start with that, Okay, from here. Okay. Say if you see the difference and it keeps on moving, am I right? Okay. So this point is 6. At x is equal to 6. Okay. This will be 2 and the radius is 4. Okay. So 16 minus 4 is 12. So this is 2 root 3. Minimum of the difference will be 0. Maximum will be 0 and minimum will be 0. So the range will vary from y1 minus y2 is 0 to 2 root. I hope you got it.
Yes, sir.
Okay. So please, this kind of problem in GMP, if you see this kind of problem they are given, one parabola and one circle, find the maximum distance between them. I forgot, it's there in GMP, but I forgot the equation. It's there in the Fidji's GMP. So it's a extended, not extended, it's kind of that kind of trick into it. So please make a note, everyone. Shall I move to next one?
Yes, sir.
Okay. Just a moment, I'm noting down the question from WhatsApp. The other question. So I'll discuss the last problem first. Okay. I'll discuss the last problem first and then move to the other problem. Fine. Okay. I give a very simple thing. Most I should not comment like that, but there is a chance that you will make a mistake. Can anyone tell this is 1 1 or not? Joshua, is it 1 1?
So I'm checking, sir.
Okay. How do you check 1 1? Anyone? You differentiate it and check that whether it's strictly increasing, decreasing. Am I right?
Yes, sir.
Okay, fine. Go ahead. Someone tells not 1 1. How? If you differentiate it, normally we check differentiation of x is how much? 1. And differentiation of 1 by x will be minus of 1 by x square. So finally it turns to be 1 plus 1 by x square. It's a strictly increasing function. It's a positive. what we learned, if it is a strictly increasing or something, it will be always, am I right?
So you can use the f of x1 is equal to f of x2 method.
Okay. Yeah, okay, we'll use it. Fine. So what someone suggests that, let us try out f of x1 is equal to f of x2. So x1 minus 1 by x2, sorry, x1 will be equal to x2 minus 1 by x2. Can I bring x1 minus x2? Okay. And minus 1 by x1 plus 1 by x2 is equal to 0. If you further do it, x1 minus x2, and if you take LCM, this will be here x1 minus x2 will come. So you get 1. Yeah, from here we get 2. From here you get 2. Yes, x2 is equal to x1, or x2 is equal to, you know, what's called minus 1 by x. The two things you get, am I right? 1. But what's the wrong in the differentiation method? I'll tell you what's where we made a mistake in understanding. If you draw the graph of this, okay, so the function is undefined at 0. I think if you simplify, you'll get x square minus 1 by x. So the function is undefined because the denominator, if the denominator is 0, anything divided by the denominator will be undefined. So function is undefined at 0. Okay, and the graph will intersect x-axis at plus and minus 1. I hope you make out. Okay, and undefined at x is equal to 0. If you recall, we draw asymptote, vertical asymptote where the function is undefined. This is plus 1, this is minus 1. And we know it's an increasing function, okay, because this is always positive, so the graph always. Basically, this 0 undefined creates a problem. So there are two branches are there, okay. From minus infinity to 1, it's one part increasing, 0 to 1, but as a whole, it's not increasing, okay, which we are not able to realize when we differentiate it. Now, if you draw a horizontal line, okay, for the two different values of x, you get the same value of y. So it's not 1, 1. So moral of the story is that observation graph that gives a, because for a problem you cannot have a x method, for b problem you cannot have a y method. You better is the observation. If you can draw the graph, it will. I'll give you. Go. Oh, there is the mask. Go and take. The smaller one. So now I move to the next problem. This one? Yes. Just a moment, somewhere I wrote the question, I lost it. Again, I have to see from WhatsApp. Can anyone dictate the question? The next one? That's some root of something. I wrote it and lost it. Anyone? I don't remember. I'll see it. Hello guys, can anyone tell the question? I'm not able to search. I need to check WhatsApp again.
So root of x1 minus 1.
No, just a moment.
Papa, Papa, you coming out? Papa, you coming out? Why no? Mommy, eating no.
Yeah, can you tell me the question? Root of?
x1 minus 1
Yeah, whole root of x1 minus 1,
plus root of x2 minus 1
root of x2 minus 1,
till root of
dot, dot,
x1000
2020, I think I wrote, minus
minus
1.
1 is equal to half times of
x1 plus
x1.
x2. Am I right?
Yes, sir.
So something you need to find out, x1 plus x2 plus x3. This is a
Yes.
very basic problem. I think
This, the answer is 4040.
yeah, I think so. Each of the value will be 2, I think, isn't it?
Yes, sir.
I don't know. Anyway, I'll tell you. You bring the 2 this side. Okay. Can I bring the 2 everyone this side and bring all the terms on the right hand side? Okay. So you get x1 minus 2 times of root of x1 minus 1. So can I add plus 1 and subtract minus 1? Okay. Plus x2 plus 1 minus 2 times of, oh sorry, here minus 1, here plus 1, here minus 1. Then dot, 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 dot. So what I get, this is a square, sorry, this is 2ab. So can I write this as a square? So a square, b square, and this will be 2ab. So root of x1 minus 1 the whole square plus root of x2 minus 1 the whole square plus dot, dot, dot. Okay. And that will be equal to 0. That will be, so sum of all positive number when it will be 0, when each of the value is 0. That's the correct. So root of x1 minus 1 is equal to 1. x1 is equal to 2. Okay. Again, x2 minus 1 is equal to 1. So x2 is equal to 2. Oh, sorry, 2. So each of the value will be 2. Dot, dot, dot. So how many times you need to add? x1 plus x2 dot, 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 x 2020. So 2 times of 2020 is 4040. Okay. Did you try those GMP problems which I posted? Hello? Anyone?
Yes, sir.
Got?
So I got 3, 4, 5, sir.
First two was which problem? Integration, am I right?
Yes, sir. I didn't try that, sir. I got remaining
Okay.
3 I tried.
Oh, fine. Okay. So, Joshua?
No, sir, I haven't tried it yet, sir.
Okay, try for 5-10 minutes, you try. Guru Shreyas,
Sir?
try out the first two. I'll give you time.
Okay, sir.
Okay. क्या हुआ जाक्ष?
Are you coming out?
हाँ 5 minutes.
Come.
अरे यार.
Are you coming?
So what I suggest you? Correct.
Yes. I'm just good. Papa, open your phone.
The first one is an awesome problem. This pattern came in IIT. I'm writing the question. अरे वो बहुत परेशान कर रहा है यार. This is the first. This pattern came in IIT JEE, but it's an extended version of the.
Are you coming?
हाँ, after 10 minutes I'll come. तुम बैठ जाओ.
No.
I'm not. This is a pure based on substitution. If you substitute the denominator, you will get the numerator. I'll search the IIT problem and show you. 2 minutes from Cengage, I'll search and show you which IIT problem I'm talking.
Are you okay?
Jaksh.
What are you doing?
Papa is searching on notebook. मत करो परेशान Jaksh.
How are you not coming? Are you coming here?
Jaksh. अरे
बोले तो चप्पल बोले उनको साइड से नहीं आ सकता है क्या
I'll try to. I don't know how to show it. This problem I'm talking about. Can you see? Hello guys, can you see this problem? This came in IIT JEE. Okay, that x square minus 1, question number 2. X square minus 1 by root. This is of same pattern, again this IIT. This also, question number 17. So all stuff are this kind of thing. So Shall I do it? Anyone can reply, or still you need? Okay, fine, I'll do it. So I'll try to solve how this kind of problem works. Like if I differentiate the denominator, the numerator should come. So if I now normally our simple brain works that if I put z is equal to the denominator, numerator should come. But if I differentiate the denominator, it will come 10x to the power 9 minus 10x to the power 4. Obviously 10x to the power 4. So obviously it does not work out if I put z is equal to this, isn't it? So this failed. And so we'll try to manipulate, we'll try to simplify or something we have to do so that the differentiation of the denominator comes numerator. So what I'm going to do, okay, I'm going to divide by x to the power 10. You may ask me why I'm dividing. 2 minutes. If I divide by x to the power 10, it will come 2 by x to the power 5 plus 1 by x to the power 10. The numerator becomes 2 by x cube plus 3 by x to the power 8 dx. Okay. Why I divided by x to the power 10? That not by randomly any degree, because you see there are 3 terms are there. 2 of them are variable and 1 is constant. I repeat, there are 3 terms were there. 2 of them are variable, 1 is constant. In the previous case, we differentiated 2, 3 of them. 2 of them was variable, something came. But the third one was, as it was constant, it became 0. Because in numerator, you got only 2 terms. Here I divided by x to the power 10. The reason is that because I want to make one of them constant. So I divided by that. So it came 1. Minus 2 of them are variable. So if I differentiate this will become 0, eliminated, rest 2. But if I differentiate 1 by x to the power 5, it will come 1 by x to the power 6, which is not matching. So this is also ruled out. Any other way we can do? Other way, you know, our brain tells that let us divide by x to the power 5. If I divide x to the power 5, you get x to the power 5 minus 2 plus 1 by x to the power 5 and 2x square plus 3 by x cube. Again, it doesn't work out because differentiation of x to the power 5 is 5x to the power 4. So this doesn't work out. I'm just trying to tell you all the possibilities which in mind it may come, but we'll be unable to do it. Now, the core challenge is that, the main challenge is that you need to substitute the denominator to get numerator. A denominator to get numerator, something you need to differentiate. And if you see in the question, it tells you to find out the values of a, b, something, and divided by, okay, I'll write the something numerator was there, but divided by x to the power 10 minus 2a. So what we guess it, the denominator remains same. The denominator remains same, only it was the headache of the numerator. So numerator was different. So something we have to do it. What kind of function the denominator remains same? So suppose this if I write this, look at it. If I would have written what I wanted to say, if I write x5 minus 1 the whole square in the numerator something, I'm trying to explain you the problem. If I differentiate, say this is of a pattern something like 1 by z square, okay, 1 by z square, say, okay, if I put, you know, the whole part to be something, and if it comes x to the power 5 minus 1 again, okay, let me, here I'm not able to explain you properly, 2 minutes. I'll solve the problem, then you'll understand better. I'm turning the page. So the numerator, what I'm trying to say, was x to the power 5 minus 1 the whole square. Okay. And the numerator was 2x to the power 4 plus 3x square. I hope I'm right. Yeah, correct. Okay. I'll tell you what I was trying to say. So basically, I have to divide the numerator and denominator by something, isn't it? Denominator by something such that the differentiation of the denominator becomes numerator. Now I am unable to guess. Suppose, you know, the intuition doesn't work. What to do? Some way we need to solve the problem. So what I'll do, I'll try to divide by x to the power 2k. Okay. If I divide by x to the power 2k, look at it. This in the book normally they give the substitution. It's difficult to guess. Okay. Why they have done it. I'm trying to explain you by this, that how it works. We'll try to find the value of k. It may help you sometime if you get a difficult substitution. So because k plus 3x square divided by x to the power 2k into dx. So the differentiation of this should be the numerator for a particular value of k. That should be the way to do it. Now, if you simplify further the numerator, sorry, the denominator, it will come 1 by x to the power, okay, let it be x to the power 5 minus k and minus of x to the power minus k, the whole square, isn't it? This inside part I need to differentiate. Okay, and it should match with the numerator. Okay, so if I differentiate this one, it will come 5 minus k, x to the power 4 minus k, and this will be k into x to the power minus k. Yes, we get it. We get it. So it will be 5 minus k divided by x to the power k minus 4, because the numerator was in that expression and k divided by, I wrote like that. Okay, this should be similar to 2 by x to the power 2k minus 7 plus 3 by x to the power 2k minus 2. For a particular or unique value of k, you know, it should fit, it should match, isn't it? So in that case, if you check out, okay, 5 minus k should be equal to 2. 5 minus k should be equal to 2. So k should be equal to 3. And it's true for all the values, you see, isn't it? So this means we are dividing by x to the power 6 in the numerator and denominator. This is a different way to solve the problem. If you have an intuition and do it directly, nothing better than that. But if we can't do it, this is the way to solve. So 2x to the power 7 plus that whole divided by x to the power cube, x to the power 6 divided by x to the power 5 minus 1 by x cube, the whole square, and obviously dx. So you get 2x plus 3x to the power 4 whole divided by x square minus 1 by x cube. Okay, the whole square into dx. So differentiation of x and differentiation of 1 by x cube is minus 1 by x cube is plus 3 by x. So you get dz by z. That's it. So ln of x square. Oh, sorry, not ln, z square. I'm wrong. So it's like minus 1 by z. Sorry, this minus 1 by z. If you simplify, you'll get the answer. Okay. That's what I was trying to say. If it remains same, so could have been something like dz by z, then it would have been remained same. So the next one also you try. All the problems you try. Tomorrow again we'll discuss. The other integration also, I'll tell you, if you have, I want a little bit hint. It is like you need to express u v dash into u dash v by u into v. If you do like this, you'll get the result. Or if you are able to express, it is like an extended version of lambda mu, what we do it. I'll post further questions, and tomorrow again we'll keep class. Okay, so I'm keeping it. That's it for today. After 5-10 minutes, I'll end the meeting. जब पापा का कहाँ पर? Oh, मेरा वाला ले लिया. You took mine. Right, you didn't take?